Now we'll continue with the student presentation. The first presentation is from the Faculty of the Technical Science. I invite Mr. Berec Gabor to present his presentation. Just to remind you, you have 10 minutes for presentation.
Hi everybody, how are you? I'm Berec Gabor. Are you satisfied with the ventilation? I think it's crucial for a KHA Congress. And so let's start with the presentation. But first of all, I want to thank for the organizers to let me be here. Everybody knows that central air conditioning in our countryside is mostly can be found in administrative buildings. The two reasons, from my point of view, for this are the economic reason, that the initial investments in central air conditioning systems are pretty high. But from the other hand, there is another fact that is worth considering, the awareness of people. People, from my point of view, are not aware how much the ventilation and air conditioning is important. So, I've done a research on a small office room, which was the subject of my research. You can see the parameters of the room and the wire model on the presentation. All of my analysis and researches were done in a CFD, computational fluid dynamics software. And the four ways of air distribution which were analyzed was the ceiling air distribution. It's, from my point of view, it's a classical solution. The air is entering from the ceiling and passes out on the ceiling or on the lower side of the wall. The second one was the underfloor air distribution. When we use a raised floor, which can both be an open plenum or a ducted plenum. On the picture on the left side we can see a ducted plenum. So the air enters from the floor and passes out on the ceiling. The third solution was a floor standing fan coil positioned under the window. It's also a classical solution, gives good results. And the fourth one was a diffuser, which uses Coanda effect. I don't know how much do you know about the Coanda effect. The Coanda effect is a physical phenomenon first spotted by Henry Coanda, a Romanian scientist. He's done a lot of research on aerodynamics. This physical phenomenon is about a fluid stream, whether it's gas or liquid. So if we have a high enough speed, the airflow, the fluid stream follows the surface, even if it's not straight, but only if we have a high enough speed. We can find commercial fan coil units which are using Coanda effect to distribute the air in the rooms. It consists classically like a fan coil unit from a fan, a fresh air inlet, the heat exchangers, condensate collecting and drain, and the most important part of it are the Coanda diffusers, which makes the air enter the room parallel with the ceiling and give him high speed to continue to spread over the ceiling. The best implementation of the Coanda diffusers are in rooms with a big ceiling area, so the air can spread rightly. I've done some calculations on the ventilation rates, which are taken from the ASHRAE 62.1 standard. So the ventilation rate should control both the building related and the people related contaminants. We have a factor RP, which is 2.5 liters per second. This airflow rate should we maintain and multiply with the zone population and get the ventilation rate, which can control the people related contaminants. The other one is the building related contaminants, which is 1.5 liters per second per square meter, and we are multiplying it also with zone floor area and get the final result of 17.5 liters per second. There you can see the results of the CFD analysis. I started with a higher flow rate than the calculated was because the results were poor. So I've raised it to 32 liters per second, and the air is entering through one diffuser, and uneven airflow you can see through the vent. So the vent, which is closer to the window on the right side, you can see, gives the highest flow rate to block the heat gains from the outside wall. If we additionally increase flow rate to 35 liters per second to one diffuser and change the angle of entering to 45 degrees, then we got pretty good results. But I've changed the configuration to 2 diffusers, as you can see on the ceiling, 2 diffusers with even airflow through both of them of 22 liters per second. But as the temperature of the windows and the outside wall is pretty high, we can see the heat gains entering the room. So with raising the airflow and changing the diffuser angles, got better results. And that's the same situation, but only from another angle. The second solution was the underfloor air distribution. This solution functioned almost with the flow rate which I calculated. It was 22 liters per second. It had 3 diffusers, 2 swirl diffusers that are circular diffusers on the center of the room, and a linear grill which was positioned under the window to keep out the heat gains. You can see the same situation and a pretty good air distribution, and the stratification, which is the best part of underfloor air distribution. You can see the high of 1.85 meters, which according to ASHRAE 62.1 is the occupied zone. We have pretty good temperatures in this zone. The yellow color is 22.5 degrees Celsius, which is pretty good. The next solution was the floor standing fan coil unit. You can see the wire model of the room and the results. So the airflow, which leaves the fan coil unit, acts like an air curtain or air wall and prevents the heat entering the room and keeps it cool, and the air distribution, as you can see on the picture, is pretty homogeneous. So we don't have parts which are hotter than the others. The fourth solution was the coil diffuser, positioned with numbers 1, and the other diffuser also with 1. And if we take a look at the picture, the air arrangement is pretty good, with a flow rate of 35 liters per second. But we should use a little bit lower temperature on the inlet, because the air enters the room on higher levels, and because of the drag, as it loses its speed, it's falling down in the room and heats up. So when it reaches the occupied zone, it gets a good temperature to be in. The conclusions, the standards for climatization in the USA, so according to ASHRAE's standards, are different from the standards in Europe. In Europe, we cool our rooms to 25, 26 degrees Celsius, but in the United States, cooling is to 22, 23 degrees Celsius. So the calculated flow of 17.5 liters per second is only sufficient to maintain these European standards, according to my research, but it's not sufficient to meet the American standards. So good results can only be reached with higher airflow rates. It's not always clear which solution we should use, because some good features of the solutions only could be seen in different types of room. For example, the underfloor air distribution have a good feature of stratification, but it could be only seen in rooms with high ceilings, because we don't need to cool the higher parts of the room, only the occupied zone, which is under 2 meters. And the other part, CFD analysis should be performed along with classical measurements to be sure, from my point of view also, I'm saying. If a method still need to be selected, it would be the underfloor air distribution, if we are not looking at the economics, but it gives the best results, best stratification, and needs the highest air inlet temperature. From the other hand, if we look at the availability and the price, the given features, the floor standing fan coil unit is the best solution. Thank you for your attention.